Hello, everyone. How's everyone doing today? Good? Awesome. So I'm here to talk to you about everything that you're doing wrong with event sourcing, which is one of life's greatest pleasures. I'm Nathan Ladd. You can find me at RealNTL on Twitter. And as mentioned, I am a co-principal of the Eventide project. It's a toolkit for building event sourcing, projects using event sourcing, as well as autonomous services. So before I begin, I noticed on the schedule, I am the first speaker presenting about event sourcing. So hopefully I can give us a brief review of what event sourcing is and save the remainder of the talks a little bit of time. If I do a bad job with my review, they'll have to, of course, explain it again and then explain why I was wrong. So hopefully I help them out. So before I talk about event sourcing, I want to just go back to basic web application stuff, and that's web forms. And I want to call web forms by a more generic name, which is commands or command messages. So this is a typical web form, and your browser submits it to your app server, your web server, and your web server handles that form command. So I'm going to call it a command message because when we're in the context of microservices and when we're in the context of a Rails app, for instance, we're all just talking about handling commands and command messages. And when you have a controller, like an MVC controller in your web app, you can also think of that as being a command handler. And the important thing there is that our handlers are the entry point of our code. So around that handler, you have framework and machinery and plumbing, but the handlers are where your code is first executed. So I want to talk about, to explain event sourcing, I want to talk about how your typical MVC plus ORM web framework handles form submission. So we have a deposit funds into an account command message. And I want to show kind of how it's handled by your web MVC framework. So first thing that happens is usually in your controller, you retrieve your model. And then you figure out what changes to make to the models. For instance, increase the account balance might be a change. And then you apply those changes to the models, usually by some attributes API, like inactive record. And then you validate the new model state. And based on that, you save the model state if the new state is valid. And then callbacks get triggered. And of course, your callbacks, when they're triggered, they can cause other models to update. And you might have callbacks that enqueue background jobs, which sends you right back to where you start. And this is the architecture a lot of people tell me is so much simpler than event sourcing. But I don't know if I can believe that, because here's the same approach in event sourcing. You handle your command by projecting your entity, and I'll explain what a projection is in a minute. You accept or reject the command just like you did before. You write an event, or you build a deposit event, I should say, and then you write it to the database, your event store. And that's it. And that projection that I talked about is really where we gather all the events that pertain to a single entity or a model, if you're in Rails land. You gather them together and you reduce them down or distill them down using a projection into a single entity or perspective of what that entity is derived from the events. And so when we've written events to a stream and we want to project it, we can kind of visualize that we're reading a stream sequentially, because that's the way we read streams. And when you're projecting entities, you always start with a blank or empty data structure for your entity, and you sequentially traverse each event one by one. And so in this case, we start with an opened event, and we copy some attributes over. And next, we read a deposited event, because that's the next event of the stream. And we increase the balance by $11, so it goes from 0 to 11. And then we handle a withdrawal for $10, so the balance goes from $10 to $1, and so on and so forth. So that is the talk. I think if anybody has any questions, you're welcome to ask. I think I'm a little bit early on time. No, I'm here to talk about all the things that can go wrong once you decide on this architectural style. And in fact, there's a lot of common anti-patterns and mistakes that I've seen teams make, and it's cost them time and money. And usually they all stem from the same source, which is continuing to perceive our software or the way we develop software from the lens of the ORM. And And really, what I want to say about this is I'm going to go into the anti-patterns. There's 4 I'm going to bring up. And the important thing to note here is mistakes are a lot more costly in an event source system because your database is immutable. And what that means is if you make a mistake in your software, when you're using a relational database, you can go and change all the data to correct it and compensate for that mistake. But if your database is immutable, you really don't have that option. There are approaches and techniques to remediating bad data in an event source system, but they all are much more expensive in terms of time and cost. So if you avoid these anti-patterns and pitfalls, it doesn't guarantee success, but I think you'll be better off if you heed them. So the first anti-pattern I want to talk to you about is entities that are aware of the messaging around them. And typically in event source systems, we handle a command message or handle a command and we publish an event. And usually there's a correspondence between the command and the event. We issue deposit and we write deposited. And all of that is messaging. And the reason I'm bringing that up is because I first want to show you what an entity is like when that entity is unaware or hasn't been coupled to the surrounding messaging. And it's really nice. You can understand and read this code at a glance. In fact, it doesn't even need syntax highlighting. And incidentally, Google Slides software doesn't support syntax highlighting. So I really love it when the universe just makes things work out. But you can understand it, and it makes sense. And if you've been using ORMs for a long time, you might even approach this entity with a little bit of skepticism. How can it be this simple to have an entity? Of course, when you're done, after some time, you're going to have a lot more baggage around it. And that's actually not true. There's a really good point made yesterday, which is your entities are core business logic. That's what belongs in your entities. And yes, you can work on and implement systems where the entities are as simple as this. And they are a lot more reliable, and they're a lot easier to work with. And you can think of messaging as periphery that integrates your entities with your user interface, your front end, other entities, your underlying operating system, other databases, other concerns. And once we introduce the concern or the responsibility of messaging into our entity, we see very, very immediately that the entity's cohesion has been reduced substantially. We've got these unrelated issues. So this method deposit now takes a command message as a parameter, and it actually decodes or interprets what the meanings of the attributes on that message are. And that the interpretation of what a message means is a messaging concern. It belongs in a message handler. And this entity also returns an event. And when you build an entity that is coupled to event sourcing, then you've really put yourself in a situation where this entity can only be used as long as you're doing event sourcing. And you must always be aware of event sourcing when you're understanding and interpreting what this class does. And in reality, the entities that I build that don't look like this, I could switch from Eventide over to ROM and keep the same entities. And everything around that is how we integrate the entity with the rest of the system. And your entities are your most core business logic. And they're the biggest, strongest asset that you have. An entity, in fact, if I look at the previous one, this almost, you can read it as a specification for what an account does as it pertains to deposits and withdrawals. So don't give that up easily. So the next anti-pattern that I want to talk about is view-biased event schemas. And this one is, I'll just explain what I mean when I say view. It's very simple. Anytime we're displaying information for our end users, whether it's auditory or visual, we're presenting them a view of information. And oftentimes those views contain data that actually, in its authoritative place, lives in multiple different event streams, or some of the data might be in an event source system and other data might be in a relational database. So building views typically with event stores doesn't work out too well, because our event stores that we use for storing events are log structured, and they can only be queried given an entity's ID. So we can't say, give me all the accounts that have had activity in the last 90 days. Relational databases are really good at that. They're also really good at tying information from different parts of your domain together and joining them to present a single view. So when we build event source systems, when we write events, we typically handle those events and update and build materialized views out of them. And if you're familiar with DDD, you probably, or you might be referring to these as these databases on the right side as read models, which is another term for them. But I just call them materialized views because that's what they've been called for the last few decades. So if this slide resembles the original slide I used to demonstrate projection, it's on purpose. Projecting events into a view database or a materialized view is really not a whole lot different than projecting them into a data structure or an entity in memory. So here's that's the background for this anti-pattern, but I'm going to give you a specific example here where we have an account transactions table and a transaction categories table. And this is the view that we want to display for our end users. We have individual transactions, but they each have a category ID. And that category ID can be used to join to the categories table and give you the name of the category. So we can figure out the first transaction was an $11.11 purchase of office supplies, for instance. So the problem that we typically run into when we start building event source systems is, for the first time, is we realize I'm trying to project this withdrawn event, for instance, and the view I'm trying to write to has this column for a category ID, and I haven't got a category ID on the event that I'm dealing with. And that's an immediate problem. You don't know how to get it there. And the tendency or the temptation is, let's just change the event scheme and attack on the category ID so that it's there when we need to assemble the materialized view. And the problem with this is the dependency direction is going the wrong way, right? We're designing our events, our core, which are part of our core domain, we're designing them to serve our UI and the data that we need to display. And when I said earlier that changes to your events and your event schemas is like the most expensive thing that happens in these systems, this is really interesting because I've added a new reason for this schema to change. If your categories are being applied, for instance, based on some heuristics that are determining, oh, you bought this, you made this purchase at a grocery store, it must be food. You bought this purchase at an office supply store, it must be office supplies. If that heuristic algorithm changes, these values might change. And so that might invalidate the data that you've written in your existing events if you were to add category ID to the event. So you really want your events to represent what occurred and nothing else. It's very important. They're a raw truth of what happened. They're not a vehicle or a conduit for you to shove in other data so that you can get the whole end-to-end experience working. And that's usually the number one thing that people coming to evented systems deal with, is they want to figure out how to build the whole UI all at once. And getting that whole picture to work immediately, there's a lot of obstacles like this in their way. And I want to kind of talk about this word tie, because I think it's slang that we use very often to talk about how different entities relate to each other. And that relationship is really a relational database way of thinking. And this is an example. The tendency and the temptation for us to do this is usually a carryover from our mentality of building systems on top of relational databases and ORMs. So the alternative here that works a lot better is to compose the whole view database from different events and isolate where events are coming from so that they don't have to all be in the same event or the same stream. And there are also additional techniques to aggregate your events so that you could produce any kind of schema you want, including a view database that combines category ID, sorry, I misspelled it there, category ID with your transactions. But I'm not going to go into that because we don't really have the time. There's a variant on this anti-pattern where people come from Rails and they're used to the errors object. And they're used to using the errors object to show validation errors in web forms. And they want that because that's how they're used to making their UI work. And the problem with this is your error is a really, it's a disposition. It's a negative disposition. As Nick was saying, it's the left-hand path. And that's a UI concept. When funds, when a withdrawal caused somebody's account to go into the negative because they didn't have enough balance, that's not an error from the perspective of the bank that collects $20 every time, or 20 euros or whatever, every time somebody goes negative. So we don't disposition events as being positive or negative. That's a UI concern. And we have to build systems this way, we really have to start distinguishing our user interface from our back-end systems or our core logic or our domain. The next anti-pattern is opaque dependencies. And by opaque, I mean you can't see, the traditional meaning is you can't see through it, but what it really connotes is that you can't control something, or that it's implicit, or it's out of your hands. And opaque dependencies can cause real problems in just about, well, in really any kind of software system. But in event sourcing, they crop up in a couple ways. The first one is making your projections opaque. In other words, hiding the projection. So if your command handler accepts as input the already projected event, then you cannot control the projection. And there's a couple problems with this. First of all, this is terrifying for beginners because they've just learned about event sourcing. And then they go into the code to understand how it works and to see how it happens. And they can't find the event sourcing anywhere. It's actually in the bowels of some framework that is external. The other problem is that you can't control the projection directly. So if you want to introduce entity caching, or you want to change the caching strategy, you have no means of doing so without the framework also affording indirect control through settings, configuration, class macros, or GASP, global state. We all know global state is a bad idea, right? Yeah. Okay. So the other reason this is a bad idea is there's actually plenty of situations where entities are not even necessary. When we are, for instance, ensuring that an email address is unique in using event store databases, we write a reservation event. We call it reservation pattern. But this particular approach for validating uniqueness is it doesn't need an entity. And so you'd have to construct one if your framework forces you to have one in your command handler. And incidentally, this approach to uniqueness is a lot like the Rails one, but it doesn't have a race condition in it that validates uniqueness of does. The other situation that I want to talk about is when we're updating those materialized views, when we're materializing those views, the entity is a view entity, and it's actually data living, for instance, in a relational database if you're using a relational database for your read model. And in those cases, you have no entity. And the final one, sometimes we have just telemetry handlers that, for instance, every time your company receives money from a payment, you might want to record a metric or record a signal. Telemetry is, if you think about an airplane, and every time an airplane crashes, which is thankfully pretty rare, there's that black box that they recover from the plane. And that black box contains the telemetry, or all of the information logs of what happens, and it can be studied for root cause analysis of why the plane crashed. Yes, and I kind of used the every time a purchase is made, you want a signal as the example, but in reality, telemetry is more of a lower level concept where we want to see how long our message is taking to get handled and what's going on in the system. So the next kind of opaque dependency is an opaque writer, and in this case, we just watched Nick's talk, and we got really excited about functional programming, and we said, I don't really want my handler to write events at all. I want it to receive as input a command and return as output events. And unfortunately, there are a couple of problems with this approach. I want to say, first of all, if the handler's job is to accomplish writing an event, the handler isn't done until the event's been written. So the handler in this state is incomplete because it's returned it's returned an event, but the event hasn't been written. And databases are unfortunately running on computers with electrons, and writing to the database can fail. And so when your handler hands off the responsibility of writing the event to some external actor, then that external generalized actor has to end up figuring out what to do if there's a failure, which is very unfortunate. And again, another sign that this handler hasn't done its job, hasn't completed it. The other thing I want to say is there's a lot of variations to how we write events and event sourcing. It's not as simple as returning events. One of the first parameters that tends to come into play when we exercise writers is something called expected version. And this is a little bit more technical, but it's a means of concurrency protection. So if you have two passenger threads, let's just say, accepting form submissions or commands that pertain to the same entity at the same time, there's a race condition. Which one is going to be first? And the behavior of the whole system might be different depending on which one of those threads wins. And so expected version is an important countermeasure for being able to deal with concurrency. But it's also very important that it is not used in every case, because if your handler, on the other hand, issues, for instance, an API call to Stripe, charging somebody's credit card, then you don't want to introduce any reason why that write would fail. Because if you charge somebody's credit card and then you don't record any event that says you charged it, then you're prone to charging them again because you've forgotten that you already charged them. And all of this to say is sometimes you need to set expected version and sometimes you don't, which means returning events from a handler is improper. It doesn't allow you to control it. And there's other variations to writing that I won't go into, but suffice it to say your handler must be able to control the writing of the message because it's not generalizable. The different situations call for different means or different techniques when you write events. And the common theme here is we need to be able to control our dependencies. And I think that's one of the most fundamental aspects of software that is oftentimes overlooked by teams because they've never done it before. We learn how to install gems like VCR that can stub out network calls for us so we don't have to control our network interactions. We mock the database using global mock so that we don't have to control whether our object interacts with the database or not. And as you build more and more complex, as your systems grow in complexity, your need to be able to revisit earlier classes that you wrote 6 months ago and test them and exercise them in all the different ways that you might want to, that ability is severely diminished if you can't control the dependencies. And in fact, in our systems, when we test our handlers, let's see, well, this is not a great example. When we test our handlers, we never hit the database because we don't need to, because we have a substitute writer that we can control. We can control the handler and change its writer to that of a substitute. All right, this is where I pick a friendly fight, and I'm gonna call out the aggregate root class pattern, and it is a friendly fight, I promise. But I have seen this pattern used by multiple clients, and it has had very unfortunate consequences in every case. And to explain what I'm really talking about, I'm talking about classes that mix the responsibilities of an entity and the responsibilities of a message handler and the responsibilities of a projection into one. And this is ostensibly done for convenience, but it causes us, as I said earlier, when our entity starts to become concerned with all these other things like messaging, it stops being an entity altogether. It stops being something that you can look at and recognize as an implementation of your domain model. And one of the major benefits that we get with event sourcing is lost when you do this, because when you can build and test your entity in isolation without needing to instantiate events, and when you can test your projection by simply giving your test an entity in some prior state and an event and testing the next state, And when you can test your handlers by simply controlling the current entity and asserting on what was written, when you can't do that, you're missing a big opportunity, because when you can, these systems become very easy to reason about and understand. And I want to kind of bring up another question that is a little bit uncomfortable. It's, why are aggregates so popular? Why do I see these everywhere I go where people have already started using event sourcing? And I think that there, even outside the Rails community, I think the vast majority of web developers have very little comfort with object-oriented programming. I think they're used to procedural and declarative interfaces where you subclass a framework artifact like a controller, and you insert your code there, and you don't really think about what is the structural design of my system. You don't move concerns into namespaces very, very often. And so by moving all the responsibilities into one class, one aggregate class, you're increasing the comfort level locally or in the short term. And I think that's the justification, but I don't think it bears out to be that beneficial in the long term. And a variant of this I've seen is a lot of teams, even more experienced people will justify this and say, well, in the beginning you don't know what your boundaries are. And because you don't know what your boundaries are, we just want to hack some code together. We want to iterate, and then we want to refactor later when we know those boundaries. And the problem with this thinking is that it's backwards. It's a lot like if you went through your house and grabbed cleaning supplies under the sink, and then you bought some test tubes and beakers from Amazon, and then you poured all your cleaning supplies in test tubes and beakers, hoping that you'd get a scientific discovery. Coding is not a practice that leads to an understanding of anything. It's a practice, it's what happens after we do the engineering and decide what it needs to be and what it needs to do. So there's an organizational maturity or a industrial or professional maturity that comes when we understand how to distinguish banging on keyboards to produce an implementation from closing our laptop lids and maybe getting on a whiteboard and figuring out what the system is supposed to be with our team. And the other reason I think that these approaches, and really the aggregate class has involved all the other, or most of the other antipatterns as well, a lot of times it's community that really leads to the proliferation of these patterns. And community is unfortunately a word that only seems to have positive connotations. And I think that I think that some of that positivity is fair, because communities can be wonderful. This is it's supposed to be animated, but it's not animating. This is a group of Amish in Pennsylvania, United States, that are building a barn in less than 24 hours. And actually, there was recently a hurricane in Texas, where I'm from, that not where I live, but in Houston, there were just tons of houses right on the ocean front. And I think I'm close to time, but I'm going to keep going anyway. There was many houses that were just blown away, and these Amish people actually left their homes and families and spent a few weeks down in Texas helping to clear out these old destroyed homes and replace them with well-built. The Amish are very good builders, and that's wonderful and inspiring, and it should be inspiring. But communities can also be incredibly harmful. They can cause psychological triggers that really subvert our critical and rational thinking processes, and they can lead us to not question things. And most importantly, when we have communities, we usually have community leaders. And when we have community leaders, we trust them. And that means that when they espouse ideas, we hold those ideas under less scrutiny, and then they can become popular. And I don't think this does a service to thought leaders. And I think, if I could probably give you a list of 100 really terrible ideas I've had in the last 2 years or 10 years that my colleague Scott has helped disabuse me of. And this is what we want. We want to feel comfortable having bad ideas be called out by people in a friendly way. And when you don't have that, people follow the Rails way, for instance, even though it leads them to ruin. And it's interesting, what I've seen in these event sourcing implementations that use aggregate classes is they can't stand Rails. In fact, they're a little bit above Rails. They're a little bit better than Rails because they've learned why Rails sucks. And And they say Rails sucks. We have all these God classes, and nothing's well designed or modular. And then we look at the implementation, and we see God classes using event sourcing. And you got to wonder if you're thinking about the tooling being the problem. Remember, the tooling never forced you to build a big monolithic application that you can't change. That was you. And if you don't correct the mistakes that you made, you're going to make them again. And if you think you're going to move to Elixir, for instance, and you're going to correct all those problems because Elixir doesn't have them, then you haven't really found the root cause. So I think it's important to always scrutinize popular techniques and methodologies. I look forward to, when I'm done, checking the hashtag for everybody telling me why I was wrong. I really do look forward to that. And be aware of how difficult this stuff is. And also be aware of your understanding of complexity, because I think what happens and causes people to stick with monoliths and make them happy with their monolith is because they feel like when I start to partition my system or I start to approach new styles, I see more complexity. I see projections and entity caching and expected version, and I never used to see those things with Rails and Active Record. And the problem is yes, there is an increase of complexity as we add these patterns, but it's not complexity that you always have to remain aware of. It's contextualized complexity. Your operating system is incredibly complicated. Ruby's virtual machine is incredibly complicated. Web browsers have tens of millions of lines of code, but you really only deal with a small subset of their complexity. So when we're building these systems and composing them of these modules, and we're using event sourcing, for instance, for not only persistence but communication between these services, you are adding complexity, but you're also allowing yourself to safely disregard most of it at any given point in time. And the last message I have is I really believe in this phrase, which is measure twice, cut once. There was a time when we criticized waterfall and we jumped into agile, and I think that was very positive. But that was at a time when it was typical to spend 6 to 18 months in upfront design, and now we're at a place where the community is usually uncomfortable with more than 6 or 18 minutes of design. And I see it over and over again with clients. If you spend a week designing just one service, and then you maybe spend 1 week or 2 weeks implementing it, that 1 week will be hell for people that are not used to designing things. And they'll call it waterfall. But it's not waterfall. It's not 6 months. It's not 18 months. It's a week of closing your laptop and figuring out what's going on. And that's the fundamental philosophy that you need to adopt to be able to succeed. And that's all I got. Again, I'm at RealNTL on Twitter. Eventide is the project. I'm a co-founder, and please check it out. I welcome you to. We're working on documentation, and it's in progress, and we're not really interested in releasing a 1.0 until we have released documentation, so that everybody's comfortable, so that we feel comfortable asking for adoption. So it's coming soon. We have used it in production quite a bit, though. So anyway, that's it. Thank you all. I appreciate it.
Questions? He won't explain event sourcing to you again.
But you can start. What is an entity? Is an entity like an object that has attributes, or is that a process?
Usually, when I'm talking about an entity and I'm talking about the code perspective, I'm usually talking about a data structure with methods around it that for instance, when I showed the deposit method that increased the balance, that's an entity. It's a data structure with domain-specific methods. There's also other perspectives of entity, like a logical one. So an account microservice might actually be thought of as an account entity if you zoom out enough, which is a subtle point, but usually I'm talking about the code pattern.
So could you actually show the slide with this entity and how you handle the event? Or handle the command?
Let's see. Wait, this is the wrong one, right?
The one where we had a handler.
Yeah, I think it's this one. This is the...
Yeah, this one is okay. So usually in many cases you would have more than one such if statement. So the reason for withdrawing the command or rejecting the command might be more such reasons. So don't you think this will end up with the feature envy smell? That you ask the object things and things before you actually tell the object to change something?
Yeah, actually, this is something that's come up before, which is if you are aware of the principle in object-oriented design, tell, don't ask. You're identifying a query where we ask the account if there's sufficient funds, and it is possible to tell the account to make a decision based on whether there's enough funds. But the problem is the outcome. So this is an if-else, and the outcome of this if-else is deciding which message to write. And that's a messaging concern. And I think it's a little bit taking encapsulation too far, the idea of encapsulation too far, to say that you can't ever have a query method. This is a method that returns true or false, which is necessary for an application to decide what to do, because we can't generalize what action to take based on whether there are or are not sufficient funds.
Because I think like this is exactly the place where I agree with the way you described the aggregate root problem, because I agree that it does couple the entity logic with the messaging layer. However, I think this is the decision that we want to make, whether we want to expose many query methods and go with the query approach overall, or go with the telling the object what to do, and then you need to couple because that was like the aggregate root, for example, as in Rails event store. This was a design choice to eliminate such code. So that's the reason we have the messaging coupled with entities.
Yeah, I don't have, so the best answer I can give you is that there is an if-else that belongs in this handler, because the handler has to decide to write withdrawal declined or withdrawn. And so that if-else, or that conditional, belongs in the handler. And so the best that the entity can do is give us a yes or no if there's sufficient funds. Now, in the case of withdrawing funds, there's only two outcomes. You either had enough money or you didn't. In other contexts, there might be many more outcomes. And the answer that Eventide has for that is that Eventide has no answer. It's up to the programmer to determine how to manage that complexity. So I think that I can't prescribe a one-size-fits-all solution there.
Yeah, just in my experience, like I wanted to avoid such code, because if it's just one if-else, that's okay. But usually you have like a more nested ifs later on, and then this code doesn't look really that cool anymore.
Well, I'll say that when I'm so before this code gets written, there's an analysis. There's an analysis of what happens when we handle a withdrawal. And we already know where we're going to get to, because we're only analyzing accounts. We're not analyzing the whole system. And so we put an accounting system that's very similar to this into production. And we didn't have to make one code change to it, aside from one minor fix. It wasn't even a fix. It had to do with something minor. I can't remember now. But by and large, we designed our accounting service and we deployed it, and we didn't have to add a single conditional for years afterwards. And that's because we understood what is innate about account withdrawals. So we epitomized the essence. We epitomized or captured the essence of what withdrawals were, and that's why we arrived at this if-else. This is not a pattern of if-else that always goes in handlers. It's frequent in handlers to have left or right, as Nick was saying earlier, but it's not the only way, or it's not the only pattern that emerges. So I guess my opinion there is, as long as your handler is in control of everything that it needs to be in control of, you can tackle that complexity however is appropriate for that entity, which is not a really good answer, but the answer usually isn't that great, or it requires you to figure out what's best for you.
So what is currently your biggest problem you're dealing with now? The biggest challenge with this approach?
Oh man, now we got to get real, huh? Everything's perfect. So here's an important. There's a couple of realities. Number one, you'll never be able to prototype with these systems as quickly as you can prototype with Rails. It is impossible. So when you want to sketch out a small web app or whatever, it's now I will say you can still implement these pretty quickly, and in many cases it is just as it happens to be just as fast. But we don't aim to be the shortest path to implementation.
I'm trying to understand the transactional property of that flow, because when you record the event like withdrawn new or withdrawn declined, it has to be coupled together with the actual withdrawal that happens in an external system or something. But you still risk that the actual operation will fail. So I'm just curious, how do you guarantee that the action of recording an event like withdrawal is actually connected with the real operation, maybe happening manually, right? They could wire the transfer by phone, whatever, right?
Yeah. Well, I think there's two considerations here. Number one, this system might be authoritative over account balances, in which case there is no external call. And number two, this is sketch code, which is really incomplete from an implementation perspective because it doesn't consider idempotence. What happens if we handle withdrawal more than once? And unfortunately, there just isn't enough time to go into patterns and techniques for idempotence. But there is a little bit more to building these systems, but not much more. Right. So if a withdrawal can only be achieved by submitting an API request, for instance, to a third-party service, then that has to happen here. And also that decision about sufficient funds does not happen here, because wherever the data is authoritative, that's where decisions can be made around the data. So you can't make decisions locally around somebody else's data, and that somebody else could be another organization and it could be another service. But data that changes together stays together, and also computational decisions based on data belong where the data is authoritative.
First of all, thanks for the talk. I'm wondering about this line when you're doing event time and setting current time to this property. So does it mean that there is an ordering of events which relies on the time?
No.
Okay. So what do you need is then?
Well, what I will say is when we typically assign an attribute called time, we're talking about a timestamp when the event occurred. But there's no necessary reason to assume that the order of the events in the database is the same order as the times of all the events.
It's just a meta information. Okay, I got it.
Yes, that is a timestamp.
So then the next question. So you got a distributed system. So how do you order the events happen in different parts of the system?
And the answer to that is to use a very technical term that is, you don't need to understand this because there's better ways to learn it, but the technical term is vector clock.
Okay, I got it.
Yeah, but
I expected that.
And you get something. Yes, but I actually when we put on workshops, and we haven't done one in Europe yet. Someday I would like to, but when we teach this stuff, we don't teach people vector clocks. We teach them the underlying problems and then how to solve them with the tools. So. Yes, it has a vector clock, but do not be scared off by that term.
Yeah, sounds great, actually. Thanks.
Yep.
I'm just wondering, when people from Rails start to use Eventide, do they, I mean, it's probably an anti-pattern. Do they happen to write those handlers instead of controller actions? Because it looks like, they will add all the code to the handlers basically, and then treat requests basically like an event. Is that something that happens, or?
Well, the first decision that people trying to adopt eventide within the context of Rails will, the first decision that one of the first decisions they'll face is whether or not to have their controller actions write a command message to a stream, or to handle the command in the request response cycle. And I will say that if you're planning a transition to microservices, you're better served by writing the command message, because then your implementation is fully portable. You can take it out of the context of your Rails app or your Hanami app, and it'll just work if you set it up right. Does that answer your question? Yeah. There was a hand raised up there in the top.
Not you.
I got you in the back, man.
How do you deal with event versioning? I mean, what if the schema of the event changes?
Yeah, that's a really good question. So when you do realize that you wrote some events with a schema that you don't want to live with, and you want to change the event schema, that's a difficult situation, and there are countermeasures. When you're doing event sourcing in the context of a monolithic application, versioning is really usually the only option you have. So you have to publish new versions of your events, and then you have to, every time you handle events, you have to figure out, is this version A or B, and then you have to perhaps take a different action. One of the big reasons why we use event sourcing in conjunction with microservices is microservices are generally small enough that they can be re-implemented very quickly. So if you identify that a microservice wrote events that were wrong enough that you need to change them, then you can build a new microservice, and then you can take the events of the old and then transform them into commands that you feed into the new, which is still a lot of work, and it's still very difficult. So my first answer to your question is, don't make a mistake. and it's hard to hear that as software developers, but every day millions of jets fly around and take people from point A to B, and they usually don't crash, Well, yeah, and the industry of airline has learned from their mistakes. One of the biggest, and you're getting me started now, one of the biggest problems with software is we don't learn from our mistakes. Instead, we switch programming languages, we switch tools, we switch jobs, we do everything we possibly can to avoid fessing up to the fact that we screwed up.
Do you typically use a centralized event store or a different approach?
That's a bit of a loaded question, because I think in the microservices world there's a concept that each microservice should get its own database. And there is a lot of merit to that in the context of relational databases, because those associations that connect one table to the other, those associations will prevent you from drawing service boundaries, because you'll have to have that data to be in the same database. In the case of event stores, they don't offer associations, and they're naturally isolated at the stream boundary. Therefore, there's really no harm in a services architecture of running all of your services against the same physical event store. That said, it's up to your operations people to decide, you know what, our account service is experiencing a high volume of transactions, and we need to scale. And one of the first easiest things you can do to scale is move that database out so that all of your other event traffic is not interfering or slowing down your account traffic, for instance. Oh goodness, keeps going. Love it. I love it.
Hi, I have a question. If you keep your data as a series of events, do these events contain the latest state, or each of them somehow contains the change of a state? And if you want to get the current state, do you need to somehow calculate it from the couple of events, or do you have some single source of truth, current one? And if not, how does this potential calculation affects performance? If you need to, you cannot just read it, you always have to calculate it, yeah? That's one thing I don't get.
So that's a good question. To go back to the beginning of the talk, we do store and persist as authoritative data the events that don't represent the current state. They represent just what happened. And in order to arrive at an entity in memory that represents the current state, we have to read each and every one of them sequentially. And this does present a number of performance considerations. But fortunately, there are very readily generalizable countermeasures. For instance, if you'll notice, each one of these events has a position that's exactly one greater than the previous one. And that means if I project this entity up to the withdrawn event at position 2, I can store a cache record that also includes, hey, this is version 2 of the entity. And so the next time I read that entity, I can pull version 2 out of the cache, and then I can start reading from 3 onwards. So we can use caching transparently to solve that problem. And then there's another performance issue of, well, if you accumulate one event for every time something happens, then you're using a lot of disk space relative to if you only stored the current state. And there's countermeasures for that too, but I won't go into them.
So one more question, do you have some kind of caching solution baked into your gem?
Yes.
Or do you have to somehow do it from scratch yourself?
Yeah, no, Eventide is a collection of libraries, and there's a gem called Entity Store. And this is a little bit of a bastardized example of it. Normally we build it and use it as a dependency, and you're seeing it referenced as a class here, but the Entity Store library already comes with a cache. And in fact, that cache has a means of introducing snapshotting as well. And what snapshotting is if you have a stream with 1 million events in it, when you restart your server, you don't want your server to have to project 1 million events the first time it's accessed. So we can periodically snapshot. And that means write a representation of the current state of the entity every 100 or every 1,000 events. So that's another countermeasure for the performance issues.
Thanks.
Yep.
Stop it.
So how do you deal with the GDPR, like the data protection, like the requirements that are like in European Union now? Yeah, okay, but we can use the event sourcing in Europe also. So
yeah, sorry, in America we can kind of do whatever we want. But regulatory requirements are part of your business domain. They're not part of a framework. So when you, and I've actually, I joke, but I've worked in healthcare industries and we do have some regulations. Most of them are designed to prevent people from competing with the big corporations that run everything, but there are regulations and you have to model them in your domain. But I haven't encountered a situation before where following regulations was a difficult thing to do with our libraries or with event sourcing.
Thank you.